Hey guys, hope you're all doing good. Today we will be first modeling the components of a engine valve system, and then we'll proceed to do the multi-body dynamic simulation. So to get started, we're going to work with the cam. So let's click on File and then click on New, and then click on Part and then click OK. Once this is done, we are just going to make sure that our unit system is set to millimeters, grams and second. We are going to use the front plane to start our new sketch. So let's click on it and view it along the normal. So we are going to get started with a center point circle. Use the circle tool. Let's just click and then we are just going to drag it out. So let's just click on the origin and then drag it out as shown. Now we are going to create one more circle just above this particular circle. So just click and drag it out like this. Hit escape. So now we are going to basically constrain these two circles to define our cam profile. So select the center points of two circles while holding the control key. Oh, sorry, I selected it incorrectly. So let me just select the centers one more time, and I'm just going to click on Make Vertical. So next we are going to assign dimensions to the circle. We are going to use the shortcut key S. Once you hit that, make sure that you select Smart Dimensions. We are going to select the bigger circle and then put in a value of 25 millimeters for the diameter. And for the second circle, let's put a value of 10 millimeters for the diameter. So now what we're going to do is we're just going to move the smaller circle. So let's just click on this guy and click on Make Coincident so that we basically constrain the sketch completely. So next I'm just going to use the line tool to draw two tangents. So let's first draw the lines first as it is, and once we draw it on the other side, you can select the line tool one more time and we can draw the line on the other side. Now let's hit escape. To add the tangent constraint, click Ctrl and select the line and the circle and click on Make Tangent and click OK. And we will be doing the same thing for the other side. Make sure that you use a Ctrl key while selecting both the entities. Let's click OK. Finally, we basically do the same thing for the top circle, right? And make sure that you do it on both the sides. Only then your cam is going to turn out symmetrical. This is an important step, so make sure that you follow this carefully. Just click on OK when you're done. So now what we need to do is just trim unwanted entities. Let's make sure that power trim is selected, and then let's just drag it out and delete unwanted sketches. So now the cam has been completely created, and now it's time to exit the sketch. Now to create the 3D cam, we just need to extrude it. Click on Extruded Boss Base and you can see the preview appears. So type in a value of 20 millimeters. Actually 20 millimeters is a bit too large. You can see that the cam is quite fat. So let's just go back and change this to 10 millimeters, and to make it easy to assemble, let's use the mid-plane option. So that way when we are assembling this component, it's going to be much more easier. So now it's time to save this part. Right, so go ahead and save it as cam.prt. Make sure that you're saving all the components of a particular assembly in a single folder so that it's easy to bookkeep. So in this case, I'm just going to call this scam. You can call it anything you want, and that's basically it. So the next component that we are going to be working on is the push rod, which is basically the cam follower. So to get started, let's click on File and New, and we're going to create a new part. Let's click on OK. As always, let's just make sure that our unit system are consistent, and then we are going to select our front plane to start our sketch. So here we are going to get started by drawing a few lines. Use the line tool and just click here and then just drag it out. Try to coincide that with the y-axis and make it coincident with the origin, and then let's drag it out to the left, drag it again to the top, and that basically looks okay. Hit escape when you're done. So then we are going to basically use a 3-point arc tool. So we're going to select this point, and the third point is somewhere here, and then hit escape. So now we're ready to constrain this guy. So let's select this particular point and the center, and let's click on Make Vertical. Now we're going to add tangency constraint to this particular arc and this vertical line, and click on Make Tangent. So now what you can do is you can just click on that particular arc and you can see that the tangency constraint is showing up. So now it's actually time to add dimensions. So click on Smart Dimension, let's select this particular line and this particular line and type in a value of 110 millimeters. And for the horizontal dimensions, we're just going to add a value of 2.5 millimeters. Just zoom in so that you can see it a bit more clearly. So now we can just exit the sketch. Now to create the push rod, we're just going to revolve this guy. Right? So let's select this particular line, which is the axis of rotation, and use the revolve tool. And that's basically it. Click on OK to finish this component. So now it's time to save this guy. So let's save this as push rod. So now that we have completed the push rod, we can move on to our third component. Our third component is going to be the rocker arm. So click on File, New, and let's select a new part and click OK. And as always, make sure that you check the unit system. And then we are going to be using the front plane to start the sketch. So let's click on front plane, click on sketch. So this time we are going to get started with a few lines, circles and arcs. So let's select the line tool first and click it somewhere here and draw an horizontal line and then drag it out again to basically create a vertical and horizontal line and hit escape. So what we are going to do is we are going to use smart dimensions and add some dimensions here. So type in a value for 10 millimeter for the horizontal line. And the vertical distance is also going to be set to 10 millimeters. And this one is going to be 15 millimeters. So now we are going to create a 3-point arc. So let's select this guy and we are going to basically select this as our first point. Second point, let's draw it somewhere here, and third point somewhere here. Basically we are trying to draw the rocker arm. There are multiple ways to go about the same thing. Here I'm just following a particular method. Oh, actually, before we do that, we need to click on the circle tool to basically create the hole that's found in the center of the rocker arm. So let's click and drag it out and let's create 2 circles and hit escape. And we are going to assign dimensions to these circles. So use the smart dimensions. And for the inner circle, let's put in a value of 12.5 millimeters. And for the outer circle, put a value of 30 millimeters for the diameter. Hit escape. So let's select the center of this particular circle and this particular point and hit make horizontal. So then let's select this particular point and this circle and we are going to click on make coincident. Now our circle is fully defined. And finally, let's select this particular point and the circle and let's click on make coincident. Now for this particular curve we are going to assign tangency mate. So let's select these 2 edges. So let's the arc first and then this arc, and then we are just going to click on make tangent. We are going to repeat the same process for these 2 arcs as well. So let's click on this one and this one and click on make tangent. Now finally we are ready to trim, right? So let's go to trim and make sure that power trim is selected, and then just remove the unwanted parts very carefully. You need to be a bit careful, right? So do something like this and you should be good. Now one last thing, we need to add one more dimension, but I think I forgot a constraint. So what we are going to do is we're going to select this particular point and this particular point and we are going to click on make horizontal and then apply the constraint. So now we are ready to add the dimensions to constrain all the 3-point arcs. So let's select this top arc and put in a value of 71.5 millimeters. And for the second 3-point arc, we are going to put in a value of 7.5 millimeters. And for the third 3-point arc, we are going to put a value of 47 millimeters. Now let's select this particular guy and this particular guy and let's put in a value of 75 millimeters. So when you do this, you can see that most of your control arm components or sketches have been constrained. So the final arc is this guy. So let's select these 2 arcs and we are going to add a tangency constraint. So when you do this, all of your sketches should be constrained. Now to finish off, we are going to be adding some fillets, so basically to round the corners. So let's select this particular point. Looks like the radius is too large here, so let's just make it to 2 millimeters, and let's try to select that corner again. Now you can see that it appears. Usually if you're able to see a preview, you should be good. So now let's select a few more corners, and let's just click on OK. Right, so that looks good. Let's click on OK, and with that the rocker arm part is complete. Now all that is left is to convert this into a 3D component. So let's exit the sketch, and we are going to use the extruded boss base tool, and we are going to be using the mid plane tool, and let's put in a value of 20 millimeters, and then let's click on OK. So now it's time to save this particular component. Use the shortcut key Ctrl+S and save this as rocker arm. Alright, so the next component that we're going to create is the valve. So to get started, let's click on File, New, and then select a new part file, and then click OK. So we are going to be sketching in the front plane, but before that we need to make sure that our unit systems are right. So let's make sure that it's in MMGS. So let's go to front plane now and click on Sketch. So in order to create the valve, we are basically going to start by creating a few lines. So let's select the line tool, and then click here and drag it out like this. Click it like this, and then just keep dragging it like this. As long as you don't hit escape, the line tool should still continue. So now if we hit escape, what we're going to do is our sketch is done. So we're going to click on Smart Dimensions and set up some dimensions right now. So for the vertical dimension is going to be 80 millimeters, and the horizontal line is going to be 10 millimeters. Oops, looks like I typed it incorrectly. So just double click on it and change it to 10 millimeters. And this line is going to have a length of 17.5 millimeters. And select this particular guy and type in a value of 8 mm. And finally, this line is going to have a length of 50.75 millimeters. Sorry, 57.5 millimeters. So now let's click OK. And then we are now going to create some 3-point arcs. So just click on this point, click here, and then drag it out and put it somewhere like this. Let's draw one more 3-point arc. Let's click here, and click here. Finally, we're going to select this point, and we're going to click maybe somewhere here, and finally somewhere here, and hit escape. Now we are finally going to draw a line. So let's select this guy, click here, and then click here. Now if you hit escape, you can kind of see that we have our valve. So now we need to assign some constraints. So let's select this guy and then click on Make Horizontal, and then just drag this out. Looks like the shape is kind of funny, so we need to select this particular point and drag it out. We'll assign the exact dimension shortly. So let's just click on this particular arc. It looks like it's currently not tangent to this line, so let's select this line and click on Make Tangent. Make sure that you have Control key pressed when you make the selections. So let's select these two arcs and then click on Make Tangent. Let's click on OK. So now we are going to use the shortcut key S to assign smart dimensions. So we are going to select this particular line, and we're going to select the top horizontal line, and we're going to hit, and we're going to provide a value of 81.5 millimeters. And we're going to say that the length of this line is 5.8 millimeters. And we are going to select this guy and put in a radius of 35 millimeters. And for this particular arc, we are going to put in a value of 1 millimeters. And finally, select the last 3-point arc and put in a value of 45 millimeters. Now let's hit escape. Now you can see that the sketch is still underdefined, right? So if you just click and drag this point, you can see which are the two things that are underdefined. So let's go to Smart Dimension. Let's select this particular point and select this origin, the local origin, and then put in a value of 12.78 millimeters. So this way, since that point is constrained, our sketch becomes fully defined. So now for this particular corner, let's round it. So let's go to the fillet tool and type in a value of 5 millimeters to this particular point. Make sure you change it and then click OK. And let's exit the sketch now. Now we're going to revolve this. So before we revolve it, we need to make sure that we select the axis of rotation. So select this particular line first. And then let's go to revolved boss base, and that's basically it. That's our valve. Now let's just click OK to finalize our revolve. And I think that looks pretty good. So let's go ahead and save this guy. So hit Ctrl S and then type in valve or something like valve_engine. So the next component that we need to create is like a valve stem. So that would be the stationary component. So let's create a new component first, or a new part first. And as always, let's check the units, make sure it's in millimeters, grams and seconds. And we're going to begin sketching on the front plane. So we're going to select the line tool first, and then we're just going to draw a horizontal line first, and then a vertical line, and then another horizontal line that's slightly smaller, vertical line, horizontal line, and we are just going to complete the shape. Now let's hit escape, and now it's time to set dimensions. So let's click on Smart Dimensions. Now the length of this particular line is going to be 10.5 millimeters, and this vertical dimension is going to be 10 millimeters. This line is going to be, the thickness is basically going to be 0.5 millimeters. Similarly, this particular thickness is also going to be 0.5 millimeters. Now you can see that the sketch is still underdefined. So what we need to do is we need to provide a distance from origin. So let's select this point and put in a value of 2 millimeters. So you can see that it is still not fully defined. So let's select this point and click on Make Horizontal. It is still undefined. I wonder why. So what we are going to do is we're just going to click on this point and drag it out. Oh, looks like we need to add a vertical constraint. So let's just click on Make Vertical. So that way the sketch becomes fully defined. So now we're going to add a construction geometry, basically an axis. So click on the line and use the For Construction option and draw a vertical line. So this is the axis about which we are going to rotate this particular component. Let's exit the sketch. So we are going to use the Revolve tool, and that's fairly straightforward. So let's click on the axis first, use the Revolve tool. You can see that it kind of creates the shape perfectly. And then let's just click on OK. So this is our last component. We are basically going to call this as valve mount or valve stem, whatever name you want. Make sure that you save it. Now you can see that all of these 5 parts are still open. The reason why I have that is it's easy to assemble, right? So to go ahead with the assembly, let's create a new file, or actually you can just use File, Make Assembly from Part. That's another option that you can use. So when you do this, you can see that all of our parts are available on the left hand side. So let's just add one part at a time. So what you can do is you can shift and select all the parts if you want, and you can just drag and drop it out. Oops, looks like I did not do it correctly. There you go. So you can see that you can drop one part at a time, right? So just click, and initially don't worry about positioning them. You can just put them anywhere. When we constrain them, everything will fall into place. So it looks like we have imported all the geometry. So now it's basically time to go ahead and assemble. So since the cam is going to be kind of a reference, we are going to make sure that we first float it, and then once we set its position, we will be able to align the other parts correctly. So now we are going to enable the temporary axis. So this helps us, align and assign our mates correctly. So we are going to get started with the rocker arm. So let's select the axis of the rocker arm, the right plane of the assembly, and click Make Coincident. Select the axis again, and if you're unable to select it, zoom in to make sure it's selected properly, and select the top plane and click on make coincident. So then we need to look at where the right plane is for the rocker arm. So let's see, is it in mates assembly? No, not really, it's actually down here. So let's select the front plane and select the front plane of our assembly and then click on make coincident. So similarly, what we're going to do is we're going to select the front plane of the cam and use Control key and select the front plane of the assembly and click on make coincident. Now let's select the axis of the push rod and Control select the front plane and then click on make coincident. So you can see that we are trying to kind of bring everything to the front plane. So similarly, what we are going to do is we are selecting the axis of our valve, the front plane, and then click on make coincident. Make sure that you are pressing Control key when you're selecting these two components. Finally, we do the same thing for our valve mount or valve stem component. So now we're just going to manually drag the push rod to something like this, right? So let's select this axis and select the right plane, and then let's add a distance mate and put in a value of 20 millimeters and then click OK. And let's just make sure that the unit system is in mmgs. Now let's just drag out the cam, and then we're going to select the axis of the cam. So let's just zoom in and select the center axis, and let's select the right plane of the assembly and then provide a distance mate and put the same value of 20 millimeters, and then let's click on OK. Now let's drag out the valve guide or the valve mount. Let's select the axis of the valve mount and select the right plane. Make sure Control is selected and add another distance mate and put in a value of 50 millimeters and then click on OK. Now let's select this particular front plane and then select the top plane, and then we're going to add a distance mate and put in a value of 60 millimeters. So that's going to be the vertical position of the valve mount. So now you can just drag out the valve and we should be able to coincide these two axes. So let's select axis number 1, axis number 2, make sure Control is selected and click on make coincident. Now let's take a look at the geometry from the front plane, and let's just click on this guy and push it. Because of our constraints, it's going to perfectly move in the vertical axis. Similarly, we should be able to rotate the cam and drag it exactly vertically down. Now we are manually setting up the position, so make sure that you see a very small gap, right? So now what we're going to do is, so we're going to select the axis of the cam and the top plane, and we're going to provide a distance mate and put in a value of 127.5 millimeters. So this is going to be the exact distance. Sorry, actually it's just 125, and click on OK. So now if you try to rotate this, you can see that it rotates perfectly. Now what we want to do is we are going to set the system up with the right amount of contact. So what we are going to do is we are going to have a small gap first, and then go to assembly and then go to move component, and we're going to use something called as physical dynamics. So the idea behind physical dynamics is where it basically moves a component till it touches with the other component, and if it does touch, the contact is basically transmitted and it goes to a point where all the components are locked in into the right position, right? So this is pretty useful because you don't have to second guess where the exact position of the push rod or the valve mount is going to be, right? So the final thing that we are going to do is we are going to open up the rocker arm and select the top plane, select the top plane of the assembly, and we are going to make sure that we put in an angle mate and make sure it's 0 degrees, right? So this way we know that these two planes are parallel. So I just wanted to check that. So we don't need an additional mate for that. So just rotate the geometry, make sure that everything looks okay. Alright, with that I would like to conclude this video. The next step is to basically do the motion simulation, and we will do that in the next video.